Hello, today we're going over 5.3, the Fundamental Theorem of Calculus. So Fundamental Theorem of Calculus, they have two parts. Fundamental Theorem of Calculus, they have two parts. So we're gonna start talking about the part one, Fundamental Theorem of Calculus, part one. So part one said, if I have a function, this function is continuous on interval, a closed interval from A to B, then there exists a function is called g of x. I can define it by using this function, the f continuous function, the continuous function from A to B. So how is the new function g of x defined? The new function defined as integral from A to B to x for the function f of t del of t. But here we have a condition for x. This x must be belong to the interval from A to B. Okay, so here I'm gonna write another note. Here I have to write this x must be belong to the interval from A to B. Okay, so I can define a function. It's called a g of x. This function is defined as the integral from the beginning of the interval, the left end point of the integral or right end point, doesn't matter. It depends in how you define the function, but it's starting from the end point at least, a to the x, to the value I need here, x the same as x, for the function f of t del of t. But also you should know this function g of x that I define it must be continuous on the same interval, differentiable in the same interval, and if I want to do derivative for this function, I'm gonna get f prime of x, this y. This is called the fundamental theorem. So I'm gonna explain it by graph. I'll explain it by graph. So I have, by the way, the integral is the area, right? Do you remember from the previous section? The integral is the same as the area under the curve if this curve is above the x-axis, or it's the net area if the function or the curve is above the x-axis and crossing the x-axis to the below of the x-axis. But here my function, here in this graph, my function f of t del of t is positive function. Positive function means is above the x-axis all the time. So this is, I can define that this curve from here to here is y equal f of t. Now I can define the function, the new function, g of t as the area. So here the area is the same as g of t. G of x, I'm sorry, g of x. So to find the value of g of x is the same as the area from starting from this point up to this point under the curve. This is the area is the same as the value of g of t. Okay, I'm gonna give you example for this to show exactly how we can using the fundamental theorem of calculus part one. By the way, I can make this here, the fundamental theorem of calculus, I can write it by using the simple letters as F fundamental theorem T calculus of calculus C and number one means fundamental theorem of calculus part one. Okay, I'm gonna give you example now to show you how we can use this fundamental theorem example. Here is the example. Okay, the example said if I have a function f is the the function f is defined as the graph shown below. This is the graph. This is the function f of t. Okay, it's shown below, and g of x is the area from 0 to x to the value. Find the value of g of 0, g of 1, g of 2, g of 3, and g of 4, and g of 5, and after that, sketch roughly the graph of g. Okay, my question now, what is g of 0? Plug inside the formula. First of all, g of x is the same as the integral from the beginning point of the interval 0 to x for f of t del of t. What is f of t? F of t is a function. This is f of t. Is the function. This is f of t. This is f of t. Okay. What is g of x? Is the area. Is the area. If I want to find the area under the curve from 0 to 1, so I call this area g of x. If I want to find the area from 0, for example, to 2, it's the area under the curve from 0 to 2, like this. This is the area. G of x is the area. Okay, my question now, find g of 0 means find the area starting from 0 up to 0. Find the area starting from 0 to 0 is a dot. What is the area from 0 to 0? Is a point. Yeah, it looks like a point. What's the area of this point? What's the area of this point? What's the area under this curve here? It's 0, exactly, it's 0. So I can write it down like this, is the integral from 0 to 0 for the function f of t del of t. And as we learned from last or previous classes, if the integral starting from the point A to the same point A, the integral is what? 0. If they're starting from one point to the same point, the limit is 0. From 10, for example, up to 10 for f of t del of t, was the integral? 0. If the integral, if the limits of the integral are the same, means the lower limit, this is called the lower limit, and this is called the upper limit. If they are the same, then the integral must be equal 0. So g of 0, like I can like here write g of 0 like this here. Okay, g of 0 is equal 0. So this is mean the area from 0 to 0 is equal 0. Okay, my second question, what is g of 1? What's g of 1? Means find the area starting from 0 up to 1. This is g of 1. What's g of 1? Is the integral from 0 to 1 for the function f of t, del of t. Okay, because I don't have the function f of t actually, I have the graph of the function. So this shape here is look like what? This region is look like what?
Triangle.
Triangle. Okay, what's the area of the triangle? What's the formula for the area of the triangle? Exactly, BH over 2 is, or I can say like the half of base times the height, correct? So here the base is what? This is the base. This is my base. What is the base here? How many units?
1.
1 unit. How many units for the height?
2.
2. So the formula is 1/2 times 1 times 2. And this is equal 1. So the area g of 1 equal 1. So this is mean the area from 0 to 1 under the curve is 1. Okay, now my second question is, my third one is, what is g of 2? I would like to move everything here to the, okay, this is g of 1. Okay. Yeah, write it like this. Nice. Here, okay, this is equal. Okay. Now, what's g of, now, second one, what is g of 2? Is the same as the area starting from 0 to 2, right? So it'd be like the integral from 0 to 2 for f of t del of t. Okay. So for the second one, starting from 0 to 2, so this is mean like this is my g of 2. Now, what's g of 2? What is g of 2 now? What's the area? Is equal to 3, correct. But how you find it?
Don't you
If you
just
break,
add the area of the triangle and add the area of the rectangle?
exactly, exactly. So G of 2 is the same as G of 1 means the area of a triangle, this one, plus the area of rectangle. This is number 1, this is number 2. Okay, number 1 is G of 1 is given, or I found it already, is 1. And the area of a rectangle is the integral from 1 to 2 for f of t del of t. Okay, this is equal 1 because G of 1 is 1 plus, now the area for the rectangle, what's the formula for the area of rectangle? What is the area or the formula of rectangle? The area of rectangle? B times H, correct. B times H means the base times the height, or like width times length. Width times length. So this is plus, like the width here is from 1 to 2. So it'll be like 1 unit times the height. The height here, how many units? Is 2, correct? 2 units. So the total 1 plus 1 times 2 is 2. So it'll be like 1 plus 2. And this is equal to 3 units. Makes sense up to now? So G of 2 means the area starting from 0 to 2. It's equal G of 1 plus 1 to 2, the integral. And this is the same as 1 plus the area of rectangle, the base times the height, or like width times the length. 1 times 2 would be like equal 2. So it would be like the answer 1 plus 2. And this is equal 3. Okay, now G of 3 is the same as G of 2 plus the integral from 2 to 3, f of t del of t. Okay, G of 2 is given from the previous one. It will be like 3 plus the integral from 2 to 3, f of 2 del of 2. Okay. Now, we need to find this small area. Actually, we found all this area before. This is the same as G of 2. Now, we need to find this small area to get the G of 3. This is the point is 3. Okay, my question is, this here, I can approximate it as a triangle. It's not a triangle, but I can approximate it as a triangle. It's look like approximation as a triangle. So the same things, what is the area for this triangle? What's the area of this? Is 1? Is more than 1 actually. It's like 1/2 times the base is 1 times the height. What's the height? Is 2. So it would be like 1, but because we have like a curve here, you see the curve? Because here's the triangle. Actually, if you want to find the triangle, here is like straight line. This is the triangle. But we have like small little bit like more area here. This area, I can like add it to the one, like 1 point, for example, 3. Make sense? So the approximate area is 1.3. Make sense? So the area here would be like a 3 plus 1.3. And this is equal what? 4.3. 4.3. Makes sense up to now? Now my question is, find G of 4. G of 4 is the same as G of 3 plus the area from, like, here's the G of 3. We start like finding the area here for everything. This is the same as G of 3. And we need to find the area from this point up to this point. From this point up to this point. So we need to find also this area. I mean, like all this area, this is G of 3 plus this area. Again, this area here, it's look like a triangle. Look like a triangle. But approximate, we can approximate the triangle. We're adding like a small area to the triangle, this things. Okay, what's the area for this triangle? This one. What's the area for this triangle? What's the area for this triangle? The area for this triangle is 1. Is 1. Why? Because we're using the formula 1/2 times the base. The base here is 1 unit actually, and the height here is 2 unit. Will be like 1/2 times 1 times 2 equal 1. And because we have like small little bit like a small more like area outside, I can like put it like the approximate area would be like 1.3. 1.3.
Isn't it negative?
Makes sense? Now, the positive or negative. Now, because it's below the x-axis, so we're gonna subtract it. Okay? The net area, because below of the under like the x-axis, we're gonna like put it as a negative. Make sense? Because it's below the x-axis, we're gonna like put it as negative. For f of t, del of t equal 4.3 from the previous one plus negative 1.3. Why negative? Because it's below the x-axis. So the answer here is what? What's the answer?
3.
3, right. So the answer here is 3. So the area from 0 to 4, I mean like the net area here, I can say net area. Why net area? Means the area above the x-axis minus the area below the x-axis. Okay, now g of 5. What is g of 5? Is the same as what? G of 4 plus the integral from 4 to 5 for f of t, del of t. The same things. What is g of 4? This is 3. What's the integral from 4 to 5 for f of t, del of t? We're going to find the area from the graph. So we need to find this area. We add it to where? To g of 4. So we find already the g of 4 from the previous one. Now we're gonna add this area. This area again, it's look like a triangle. The area of the triangle is 1/2 times the base. The base is 1 times the height is 2. So the answer is 1. But we need like a little bit like more space from this side because the triangle here is a straight line. So it will be like 1.3 again. And it's because below the x-axis, we're gonna subtract it. So it will be like equal 3 plus minus 1.3. And the answer here is equal what? What's the answer? 1.17. This is called again net area. Any questions so far? Any questions so far for this example?
I have a question. What if the function was given instead of just f of t?
What's happened?
So we could just plug in the numbers. What if the function was given instead of just f of t? That we could just plug in the numbers.
No, you cannot plug the numbers. Hold on 1 second. If it's yeah, you can plug it because they're gonna give you the minus already when you plug the values. Correct. But sometimes because right now, up to now, we did not learn how to do integral for the function. For example, if f of t is given like this, x squared, for example, right now, up to now, we did not learn how to do integral for the function f of t. We can learn it during this class. Okay, that's why this section is starting by giving a graph because already we know how to find the area of under the curve for like rectangle, for triangle, for everything like this. That's why the function did not give me, like in this example, not starting by giving a function like polynomial function or like regular function. Why? because, like I said, we did not learn how to find the integral so far. We learned how to do the integral by using the limit sum from the previous sections. But today we're gonna learn how to do it direct without using the limit sum, because the limit sum takes long time to find the integral. Okay, now also the second part of this example, they ask to graph roughly for the function g of x. The graph here, the graph of the function g of x. Okay, at the point 1, what value for the function? At point 0, what's the value for g of 0? Is 0. At g1, at the point 1, what's the value of g1? Is 1. So increasing. G of 2, what's happened? 3. Still increasing. G of 3, what's the value? 4.3. Still increasing. G4, what's happened? Goes back to 3. So from 4.3 goes back to 3. This means the function is what? Decreasing. At G4, 5, what's happened? Decreasing again. So the function increasing up to the point x equal 3, then decreasing again after like x equal 3. So I can graph the function by using the plot points. So we're gonna get a graph similar to these things. This is the graph of the function g of x. Just a plot points. So again, at the point 0 is 0. At the point 1 is g of 1 is 1. Here's 1. At 2, the value is, look, at 2 is 3. Is 3. At point 3, the value is 4.3. Is 4.3. At the point 4, the value is 3. Is 3. At the point 5 is 1.7. Is 1.7. Make sense? I'm gonna like graph a small lines like this. Like here's the line. First one. Here's the first one. Duplicated. Here's the second one. Duplicated. Here's the third one. Here's the third one. And here's the fourth one. And here's for the 5. Gonna fix it. Here's for the 4. Here's for the 5. The 4. Here's the 5. Make sense? How we can graph? It's not hard. Okay. This is what you should know about the part 1 of the fundamental theorem of calculus. This is only the things you have to know about the fundamental theorem of calculus. Now I'm going over like the second part of the section is the fundamental theorem of calculus part 2. But before we go over the part 2, I'm sorry, I'm gonna give you like more examples to explain exactly, like to show you exactly how we use the theorem, exactly how you use the theorem. So some notes here, very important notes. You should know that g of x plus h minus g of x over h is the same as 1 over h. G of x plus h minus g of x. Now, if I want to like substitute these things by using the integral notation, this is equal what? This is equal what? 1 over h. The integral from the first point or the starting point is called a, the left end point of the interval, for the function f of t, del of t, but the second limit of the integral is x plus h. Okay, minus the integral from a to the end point of the integral is x for f of t, del of t. Okay, these things here, I can like break it down by using the theorem as I learned from the previous section. Did you remember this theorem? Like this one? Let me show you exactly. The integral from a to b for the function f of x, del of x, plus the function, the integral from b to c for the function f of x, del of x. This is equal what? The integral from where to where? From a to c for the function f of x, del of x. So the same things here. The same things here. So here the same things. The same things for a from a to x plus h. So I can break it down from a to x plus x to x plus h. Make sense? Make sense what I said? I'm gonna break it down as 1 over h, open parentheses, from a to x for the function f of t, del of t, plus the integral from x to x plus h for f of t, del of t. Okay, then this is minus the integral. Get everything inside the parentheses, this big parentheses, f of t, del of t from a to x. Now I can like eliminate or like canceling out these things by what? By these things. Why? Because we have a minus here. You see the minus? Like we a minus b. So we subtract. So what we left? What we gain after that? What's the final answer? This is equal what? 1 over h, the integral from x to x plus h for f of t, del of t. Any question? This is what you should know. Starting from x to x plus, like if I have something like that, I can write it like this. Okay. Second note, second important note, this is number 1. Here's number 1. Here's number 2. Second note said, if I want to like do derivative del over del of x for the integral from a to x for f of t, del of t, this is the same as f of x, f of x. Why? How I think by this? I can say it like the integral with the derivative, they cancel out. Then I have to plug this one inside the function f of t, f of x. Again, the derivative with the integral, they cancel out. Then I have to plug this one inside the function f of x. I get a question, should not to be like x plus h to x? It should not to be x plus h to x. No, why? Because here, like I broke down these things, starting from a to the x, and from x to x plus h. So the x and x, they are the same. So they can combine to be like the same as this integral from a to x plus h. Here's a to x plus h. And because here we have like negative for this integral is negative, and the same quantity is here, so they can cancel out. And we left from x to x plus h for f of t del of t for the instant integral. Make sense? Not from x plus h to x, no, from x to x plus h. Multiplied by 1 over h. Okay. For the second one, the derivative, they can cancel out the integral, then plug the x inside the function, f of x. Example. Find the derivative of the function g of x equal the integral from 0 to x for the function square root of 1 plus t squared del of t. What's the answer? What's the derivative? By using the formula here, by using this formula, what's the derivative of this one? These things? What's the derivative of g of x? Is the same as inside the integral. What's inside the integral? Yeah, go ahead.
Do you want me to give you the answer or just the
answer?
derivative?
Give me the answer. Give me the answer.
So the answer would be just vertical x plus vertical x 1 plus x squared.
X squared, correct. Correct. So del over del of x of g of x is the same as del over del of x for the integral. For the integral from 0 to x for distance 1 plus t squared del of t. Okay. But you have to give some notes here, like you have to set the function I'm gonna like move this like down 1 second, like this here. The function f of t, what is the function f of t here? Is the same as square root 1 plus t squared. It's continuous function. So first things before you start finding the derivative for any function, you have to, or not you have to, you must to find the continuity. If the function is not continuous, you can't continue. You cannot find the derivative. It's continuous function. It's very important to be continuous. Why? By using these things, I can use the fundamental theorem of calculus part 1. If it's not continuous, I cannot use the fundamental theorem of calculus. Look, the fundamental theorem of calculus said f is continuous. If it's not continuous, I cannot continue. I cannot like solving the question. So here, continuous function, because the radical, like as we learned from before, it's a continuous function everywhere. I mean, like inside positive values on its domain. It's continuous function by using fundamental theorem of calculus part 1.
But what if it's not continuous? Then what we do?
Maybe you can find the derivative, maybe not.
Okay.
But you have to find for continuous. For continuous, for sure we have derivative. For sure we have a derivative. So we can like taking the derivative for both sides here. Like I take the d over del of x for g of x, del over del of x for the integral. So this is by using the integral, by using the fundamental theorem of calculus, this is equal what? Like Fahim said, this is the same as the radical of 1 plus x squared. Done. Done. That's it. So here I can like write it as g prime of x. So I can say g prime of x is the same as the integral the radical is the same as the radical of 1 plus x squared. Make sense? Another one, another example. Find the derivative of the function s of x equal the integral from 0 to x for the function s as sine of pi t squared over 2 del of t. Okay. My question is, does f of t equal sine of pi t squared over 2 continuous function? Does it continuous? What do you know about the sine function? The sine function. Doesn't matter, it's inside the sine. Doesn't matter, don't look here. What do you know about the sine function? It's continuous anywhere. The sine, cosine function, all the time continuous. So what do you know about these things? This means the function here is continuous. F of t is continuous. Is continuous function. So because it's continuous, I can use the fundamental theorem of calculus part 1 by using fundamental theorem of calculus part 1. S of x prime equal what? What? What's the answer?
Is this sine pi over 2x squared?
Sine, exactly. Sine by x squared over 2.
Yeah.
Yes, yeah, correct. Okay. Another one. Example. Find del over del of x for the integral from 1 to x to the power 4 secant of t del of t. Here is everything, like here in this example, there is something different. What's the different things? The function, like the integral, starting from point to function, like not simple function. I mean, this is not a simple function. It's not x. Here is x to the power 4. X to the power 4 is completely different about x. To find the derivative for x, if it's x here, we're gonna use the by fundamental theorem of calculus part 1. So the answer will be like secant of x. But here, because we don't have an x, we have x to the power 4. Everything will be different completely. So here I can define this function as g of what? What is inside? What is inside? If you go back into the if you back into the fundamental theorem of calculus, this here must be equal to these things. Again, these things must be equal to these things. G of x, like if you have, for example, m, must be m here. If we have, for example, 7x, here we have like to get 7x. We have to. But right now in this example, we have x to the power 4. So g of x to the power 4. Okay, back to the example. So this is equal g x to the power 4. Okay, take the derivative for both sides. Del over del of x Here del over del of x. Okay, what's the derivative of the right side? What is the derivative of these things?
4x cubed.
G prime of x to the power 4 times what? 4x cubed. Okay, and this is the same as what's the derivative of these things?
Isn't the answer should be like 4x cubed secant x to the 4?
Exactly. So whatever, like here, like these things, it must be like the same as g prime times this value. Okay, is the same as f, like I have to write here, f of x to the power 4 times this value, 4x to the power 3. Now, what is f of x to the power 4? What is f of x to the power 4? Is the same as secant to the x to the power 4 times 4x to the power 3. Make sense?
Alright, so instead of like instead of one, it was like x squared, right? Then we would have to
Yes.
do like subtract x or 2x to the
If we have
secant
it,
x squared, right?
what's your question? If here x square?
No, on the bottom, the instead of 1 is x squared.
No, it is supposed to start from number. You have to start from number. Here, like, must be number. It cannot be like a
So always
function.
have to be number?
No, must be like 2, 3, 4, whatever. Cannot be a function. But the other sign is supposed to be a function.
Oh, because I did the problems has like both are the functions.
Like you get a problem here, function to function.
Yeah. So
What
you
is the
just like it's just subtract B and A to get the answer.
like here you get a function to function?
Yeah.
Like which example?
Oh, I did my on the tutoring session. So
Maybe like if you get a function to function, you have to use the property number 7 we learned from last class, or like this property, like this one. I mean, like you have to start from like number, like this one.
okay.
You have to make it similar to these things. From A to B is this A to B. Like the A starting from number, for example, 1 or 2 or 3. If you have the question, just send it to me by email. Okay. For something like that, if you want to find the derivative, you have to plug the value x to the power 4 inside the secant. Then you have to define the derivative of in the top. Okay. Again, if you see something like that in the future, like that derivative should be like f of the function in the top. Like for example, m. I wanna like write it in general. I wanna do it in general. Here's the general one. So if I have, for example, find del over del of x for function from a constant to a function, like for example, I'm gonna call this function as del of x, I think. Okay, for the function f of t, del of t is the same as f of the function del of x times the derivative of del of x with respect to the x. Del over del of x for the function del of x. Make sense? Again, this is my del of x. This is del of x. This is the derivative of this function with respect to x. Okay, now let's go to the second part of the fundamental theorem of calculus. This is the first time. This is the first part. We are done for the first part. Now let's go to the second part. Like it's called fundamental theorem. Fundamental theorem of calculus, part 2. Okay, the fundamental theorem of part 2, like they said, by using this definition. Here's the definition. For this part, we're gonna find the antiderivative function. You know what's the antiderivative function? As we learned from the previous chapter, the antiderivative function is the function. If we do derivative for that function, I'm gonna get the function inside. So again, let me read what the fundamental theorem of calculus part 2. So f is continuous function. This is very important. This is a very, very important. Must be continuous. The function f must be continuous.
Oh,
And the
yeah,
interval
sorry
from A
to,
to B. Then,
cut you off. I was talking about this, my bad.
okay. This is the fundamental theorem of calculus. This is the fundamental theorem of calculus part 2. This is different about the first one. First one, from starting from constant to, for example, constant to x. But this one, like starting from constant to constant.
Isn't it like
From
basically the
number to
same
number.
thing? As if the
Same things.
derivative of constant is just 0.
Correct.
So it's basically the same
Like
thing.
similar.
Yeah.
Similar, yes. Yes. So this is the f of x must be continuous function on the interval. The integral for this function is supposed to be like f of b minus f of a. I can write down these things as something like that. F of x, like that. And here is the limit of the integral. So first of all, you should to find the antiderivative function of this one. The antiderivative function means the backward of the function. You have to go to the table. I gave it to you in section 4.9. And you have, I think, a quiz today for these things. You have a quiz today for these things. You have to know what's the antiderivative for any function I gave it to you. For example, if I give you like the function x squared, what's the antiderivative for x squared? By using the formula x to the power n. You remember what's the antiderivative for the x to the power n? Is x to the power n plus 1 or n plus 1. Like x to the power 3 would be like x to the power 4 over 4. This is called the antiderivative for this function. If I give you like the function sine of x, what's the antiderivative for this function?
Cosine
Negative
x
cosine?
Minus
cosine x.
cosine of x. This is the antiderivative. So you should first of all find the antiderivative function. After you finding the antiderivative, this is called the antiderivative function. You plug the values b one time, you plug the a one time. So f here is the antiderivative of f of x, such that like if you do derivative for the big one, like for f of x, you're gonna get the small one. We talk about this in 4.9. Okay, let me give you example to explain exactly what's happened, how we can find the antiderivative, how we can evaluate the integral by using the the part 2 of fundamental theorem of calculus. So evaluate the integral from 1 to 3 for the function e to the x of x. Okay, what's the antiderivative for e to the x? From the table in section 4.5. What's the antiderivative
e to the x
for e to the x? Is the same, is e to the x. But before we starting solving any question for the integral, you have to check if the function is continuous. So my question is, f of x here is equal e to the x. Is it continuous? Does it continuous in the interval from 1 to 3? Does e to the x continuous function from 1 to 3? Any issue if you plug any value from 1 to 3 inside the function, they give you issues? No issues. The function is clear from 1 to 3. The function is clear. So the function is continuous in the interval from 1 to 3. Is continuous on the interval from 1 to 3. So now I can use part 2 of Fundamental Theorem of Calculus. I can use these things. So this thing said you have to find first of all the antiderivative function, the big one. What is the antiderivative function of e to the x? Like you said, is the same as e to the x. How I know it? By using the table. Which table? The table I gave it to you in the 4.9. And you had a quiz today for these things. Okay, f of x equal e to the x. The f capital of x is e to the x. Now we can like evaluate the integral by using the fundamental theorem. You see, how is the formula? Here's the formula. The integral for the function f of x, del of x from a to b is the same as f capital of x, then plug the values b to a. Okay, so the integral for e to the x, del of x from 1 to 3 is the same as f capital of x from 1 to 3. And f capital of x is what? Like we said before, as you see before, it's the antiderivative is the same as what? E to the x. So it would be like e to the x, plug the values from 1 to 3. Okay, this is equal e to the 3 minus e to the 1. Done. This is the value of the integral. Make sense? So this is e to the 3 minus e. Make sense? Any question? How to find, like how to evaluate the integral? By using the fundamental theorem of calculus, you have to find the antiderivative. You have to check the function is continuous. Okay, another example. Find the area. Under the parabola. Y equal x square on the interval from 0 to 1. The area is the same as what? The integral. Area is the same as, find the integral for x square, del of x from 0 to 1. Okay, my first question. Does the function y equal x square continuous or not? On the interval from 0 to 1.
Yes, it is.
Yes.
Yes, it's continuous, correct. The function is continuous on the interval from 0 to 1. So I can use the fundamental theorem of calculus part 2. We can use fundamental theorem of calculus 2. Okay, now my second question. Here I don't like to write like y. I would like to write f of x, small f of x like this. Okay, my second question, what's the antiderivative function? What's f capital of x? By using the formula. What's the antiderivative of x squared? Correct, Freddy. X to the power 3 over 3, correct. Now we're going to use these things to evaluate the integral. So the integral from 0 to 1 for the function x squared del of x is the same as f capital of x from 0 to 1, and this is the same as x to the power 3 over 3 from 0 to 1. Okay, plug the values now. you're gonna get what? 1 over 3, like 1 to the power 3 is 1 over 3 minus what? 0 over 3. And this is equal 1 over 3. And this is correct. We saw these things before. You remember, like in the second section, when I ask you, find the integral of this function by using the limit sum. When I ask you to find the limit of, find the integral of these things, or find the area of these things by using the limit sum, and we approximate it, we find it exactly as 1 over 3. And the same answer, we get the same answer by fast way is by using the fundamental theorem of calculus. Make sense? Any question? Example. Find the integral from -1 to 3 for 1 over x to the power 2 derivative of x. Okay, this is equal the same as what? The integral of x to the power -2 del of x from -1 to 3. Okay, what's the value for this integral? Can we use the fundamental theorem of the calculus for this integral, for this function? What is my function again? F of x. Here's my function. Here's my function f of x. F of x equal 1 over x squared. Okay. Can I use the fundamental theorem for this function from -1 to 3? No. Why it's no, Fred? Why I cannot use the fundamental theorem of calculus for this function? Exactly. Nice, nice, nice. Because the function 1 over x squared is not continuous in the interval. Is not continuous on this interval. Why? The function does not have a value at 0, correct? The value here for the interval here is not, the interval here, the interval is from -1 to 3. But the function here, this function is not continuous at 0. The 0 is belong to this interval. So I cannot use the fundamental theorem of calculus here. I cannot use it. So I have to write is not continuous at x equals 0. That's belong to the interval from -1 to 3. So I cannot use fundamental theorem of calculus 2. These things we're gonna learn how to do it. Like we're gonna learn it in calculus 2, how to find integral of something like that. Actually, I'm gonna give you like a hint. This things, the integral from -1 to 3 for the function 1 over x squared del of x, the value does not exist. So far, right now, it does not exist. But in calculus 2, we're gonna learn this value actually is this integral equal infinity. This integral equal infinity. Okay. So far, just write down the integral does not exist. Any question? Okay, here is the general things you have to know for this class, and then we finish this class. The fundamental theorem of calculus has 2 parts. The fundamental theorem of calculus, they have 2 parts. The first part is g of x equal the integral for f of t, del of t starting from a to x. The second part is the integral for function a from a to b is the same as you have to find the antiderivative function, then you have to plug the value b and a inside the antiderivative function. Then this is what this is the only things you should know about this section. Here, the fundamental theorem of calculus. Any question? Any questions? So the fundamental theorem of calculus, they give us like a very important notes to use or how to use to evaluate any integral. Would that mean area equal infinity? Yes, the area equal infinity, Freddy. Correct, for the previous one. The area equal infinity. No limits. Okay, let's go to the new section. This 5.4. Let's talk about the indefinite integral. Integrals. So by using the part 2 of fundamental theorem of calculus, I can find any integral for any indefinite integral, and the net change theorem. Okay, so before we learn how to find the integral, to find the integral like this of x delta x equal what? Limit sum, limit when n goes to infinity, sum I equal 1 to n for f of xi delta x. What is delta x? What's delta x?
B minus a over n.
Exactly, b minus a over n. N is the number of subinterval. And xi, what is xi? Sample point. This is how we learn like before, but today we're gonna learn how to do the integral without using the limit sum. Okay, without using the limit sum. So what we're gonna learn? So we're gonna learn like the integral for f of x. That of x is the same as the antiderivative function, like this. What does that mean? Means if I do a derivative for this function, the big one, I'm gonna get the small one. F prime of x, if I do like derivative for the antiderivative, I will get what? F of x. For example, find the integral for example, x squared del of x. What's the antiderivative for x squared? X to the power 3 over 3. What does that mean? What does that mean? X, what's the derivative of these things? Del over del of x for x to the power 3 over 3 is equal what? 1 over 3 times what? 3 x squared, and this is equal x squared, and this is equal f of x, the small one. Makes sense? Now, like, it's become so easy to find the derivative. Here I can like add c. Why add c? Because if I want to like do derivative for plus c, this is the general, it's called the general antiderivative. Like if I add c, When I do derivative for the number c, I'm gonna get 0 plus c. Okay. So now, like, to find any integral is so easy by finding the fundamental, the antiderivative. You should to think for the integrand side as the antiderivative. Make sense? So again, if I ask you what's the integral for any function, you should to find the antiderivative function. Then if it's definite integral, you're gonna plug the values. If it's indefinite integrals, you're gonna keep the answer as a function. So what's the difference between definite and indefinite indefinite integral? This is my question now.
Definite
What's the
integral
difference?
has for answer for definite integral is a number, and for
Number.
the indefinite, it's just a function.
Function, correct. Yes, correct. Because, for example, I can define like definite integral is denoted by, like, it has integral with limit, with limit a to b. A and b are constants, and the value here is number all the time. The value is number, is not a function. Value, number. Okay. This is called about the definite integral. This is the definite integral. Again, the definite integral, the integral has a limit from a to b, and the value is what? Number all the time. The value is number all the time. But indefinite integral is denoted by the integral without the limit. And here's the answer is what? What's the answer? Function. Function of what? Function with respect to the x. Function of x. Make sense? This is the difference between definite and indefinite. Definite, they give me a value. Indefinite, they give me a function. Okay, how we can combine the definite and indefinite function integral? How we can combine both of them? Here's the competition between them. Connect between 1, this is number 1, this is number 2, and 2, like this. The integral for the definite integral from a to b for the function f of x, del of x, is the same as indefinite function of x, del of x, but we have a value outside like this. Like here b from a to b. Clear? Definite gives area, while indefinite gives antiderivative. Correct, Freddy. Definites, they give me area or number, value, 5, 6, 7, 9, whatever. Indefinite, they give me a function, antiderivative function. Correct, antiderivative means function with respect to x. Correct, Freddy. Juan, Juan, he said the indefinite integral does not, no bounded, correct, no bounded, no values. This is correct, no bounded. Okay. So definite has, they give me a number, indefinite function. Now, I'm gonna give you a table. This table is very important. It has all the antiderivative functions. Here's the table. This table, if you know exactly or memorize it, you're gonna solve any integral function. You can find any integral function for this things. So you have to memorize this table. You have to memorize. So the integral for c times function f of x, I have to take the c outside, then do the integral for the function. This is number 1. Number 2, if I have a constant k, it's the same as kx for indefinite. This is all the function here, indefinite. Does not have a bounded, does not have a numbers. Okay, x to the power n. What's the integral for x to the power n? Is x to the power n plus 1 over n plus 1. Okay. Okay, again, so this function, all of them are called indefinite because is not bounded, and all of them are familiar for all of you because it's similar to the function as we learned for the antiderivative. So ask yourself, what's the antiderivative for k? Is kx. What's the antiderivative for x to the power n? Is this thing. What's the antiderivative of e to the x? E to the x plus c. You have to add the cy because it's in general. What's the antiderivative for sine function? It's minus cosine. What's the antiderivative of secant square? It's tan. What's the antiderivative of secant tan? Secant. What's the antiderivative for 1 over x squared plus 1? Tan. What's the antiderivative of 1 over square root of 1 minus x squared? Sine inverse. What's the antiderivative of b to the x? Is the same over b of ln of b over the derivative of x. What's the derivative of x? Is 1. So here multiply by 1, but it's hidden. What's the antiderivative of 1 over x? Is ln of the absolute value of x, and so on. What's the integral for function like that? You're gonna distribute the integral inside the parentheses. And the same things for the minus. What is the minus? I think, no, the minus is not here, but the same things if I have here minus. What's the antiderivative of sine hyperbolic x? Is cosine. What's the antiderivative of cosine hyperbolic x? Is sine. Here is no sign. He did not put like minus or negative. Like look here, for the integral for the sine is not minus, similar to this. Look here. The integral for sine of x is minus cosine of x. But the integral of sine hyperbolic is positive all the time. All the time is positive. Any question?
So anything with hyperbolic is positive, right?
Yes, for sine, cosine, and tan. But for the something else, no, they have some negative. They have some negative. But you should know only these things for the sine and cosine. And the tan, the three of them are positive. But cotan and cosecant and secant is negative. You're gonna use the negative for like, you're gonna use, you don't need it, but you should know right now the integral of sine hyperbolic, cosine of hyperbolic. Okay, example. The example, find the general integral for the function 10 x to the power 4 minus 2 secant square of x del of x. Okay, what's the integral for these things? First of all, as you see, the function has two, like inside the integral, we have two functions. This is the first one. This is the second one. So we're gonna use this formula in the beginning. We're gonna distribute the integral inside the parentheses. Make sense? Then step number 2, after you distribute the integral inside the parentheses, you have a constant in front of the function, similar to these things. If I have a constant in the front of the function, I can take the constant outside. Make sense? Okay, let me do it. So this is equal the integral for 10 x to the power 4 minus integral, del of x, don't forget del of x. Del of x minus the integral for 2 secant square of x del of x. Okay, the 10, I'm gonna take it outside, like I said before, then integral x to the power 4 del of x minus 2 integral secant square of x del of x. Okay, my question now, what's the integral for x to the power 4 by using this formula?
To the fifth
We're
over
gonna use
5.
this formula. Exactly, x to the power 5 over 5. What's the integral of secant square? Which formula I have to use?
Tan x.
Exactly this one, tan of x. Now, what's the answer? Then
2x
what?
to the 5th minus 2 tan x plus a.
X to the power 5 over 5, correct? Minus 2 tan of x. Plus what?
C.
Don't forget the plus c. Why? Because they ask for the general. General, you have to plus c. If you not put the c, you're gonna lose 1 point. Okay, let me simplify these things. The 10 with the 5, the 10 with the 5 will be get 2 x to the power 5 minus 2 tan of x plus c. Any question? Any question? Makes sense? Okay, another example. Find the integral for 2x to the power 3 minus 6x plus 3 over 1 plus x squared del of x from 0 to 2. This is definite or indefinite integral? This integral is definite or indefinite?
Definite.
Why?
Because it
Because
has an interval.
exactly, they have a limit for the integral from 0 to 2. Okay. So you're gonna like find the like you're gonna find the same steps like definite, like you're gonna use the same step like indefinite. Then in the end, after you finding the indefinite integral, you're gonna plug the values. So again, this is the same as what? The integral of 2x to the power 3 minus 6x plus 3 over 1 plus x squared del of x. Then after you find the limit, the integral, I'm sorry for this. After you finding the integral, you're gonna plug the values from 0 to 2. Okay. Now my question, what is the integral for these things? Again, the same step, like you're gonna distribute the integral inside the parentheses. The constant, they're gonna take it outside. This is constant, take it outside. Then you're gonna find that integral. Okay. Who gonna help me for this one? What's the integral? Like what's the, like give me the procedure, what I should do?
I just give you the answer.
Yes, please.
It's 1/2 x to the 4th
1/2.
minus 3x squared plus 3 tan inverse x plus c.
Again, 1/2 what?
X to the 4th
X to the 4
minus
minus,
3x squared
okay,
plus 3
plus
tan inverse x plus c.
C. Now, without the C, you don't have to put the C here.
Oh yeah.
Why?
Okay.
Because it's definite. Okay. Then you plug the values, correct? From 0,
Yeah.
from 2 to 0. Okay. Let me do it very quick, and I want to check my answer is similar to your answer. So we're gonna distribute the integral inside the parentheses like this. So it will be like 2x to the power 3 minus integral 6x plus the integral 3 over 1 plus x squared, and all of them, don't forget the del of x, del of x, del of x. And after that, after you finish everything, plug the 2 and 0. Okay, now for the first integral, this one, the integral here will be like 2x to the power 4 over 4. Why? Because the constant, we take a constant this outside. This constant outside and this constant outside. Okay, minus 6 x. What's the integral for x? Is x squared over 2 plus 3. What's the integral for 1 over 1 plus x squared? Tan inverse of x. After that, you're gonna plug the 2 and 0 one time. Okay, I'm gonna simplify it here. The 2 with the 4, so I get x to the power 4 over 2 minus the 2 with the 6, I get 3 x squared plus 3 tan inverse of x for 2, 0. If we back to the answer like Fahim said, it's similar to his answer. Like 1/2, here's 1/2, x to the power 4 minus a 3, correct, 3x squared plus 3 tan inverse. This is correct. And then you plug the values from 0 to 2. Same answer. So my answer is correct. Now, we're gonna plug the value. Plug the 2, first of all. What do you get? Plug the 2 for all the equation. What do you get? 2 to the power 8. 2 to the power 4. What is 2 to the power 4? What is 2 to the power 4? So 2 to the power 4 over 2 minus 3 2 square plus 3 tan inverse of 2. We plug the 2. Now we're gonna plug the 0. Minus, plug the 0, what do you get? 0 over 2 is 0, minus 3 times 0 is 0, plus 3 tan inverse of 0. What is tan inverse of 0? What is tan inverse of 0? Tan inverse of 0 is 0, correct. Now let me simplify it. So all these things, I'm gonna get 0. 0 minus 0 plus 0 is 0. Okay, let me do the left-hand side. 2 to the power 4 is the same as 16. 16 over 2 is what? What is 16 over 2?
8.
Is 8 minus 3 square is 2 square is 4. 4 times 3 is 12. Plus the tan inverse of 2, I'm gonna keep it tan inverse of 2 because I don't know what's the value until I use the calculator. Okay, the answer is now 8 minus 12 is what? Minus 4 plus 3 tan inverse of what? Of 2. Here we don't have C. Why we don't have C? No C here in this question. Why no C?
Because it's a definite interval.
Exactly, because it's definite integral, because it's a definite integral, so no C. Definite integral, so there is no C because the integral is definite. Make sense? Clear? I'm gonna give you like exercise, homework or exercise. Home work. You should do it. Find the derivative of the function. The function I'm going to give it to you is not the derivative. I'm sorry. Find the integral. Find the integral of distance cosine of theta over sine square of theta. You have to find it. You have to find the integral for distance. Okay. Now, after all these things, we need to go over like something is called the net change theorem. Net change theorem is not something like new. The net change theorem is similar to what we did before. So here I'm gonna say like the net change theorem. Again, the net change theorem is not hard. It's similar to what we talk about. So by using Fundamental Theorem of Calculus Part 2, we learned that the integral from a to b for the function f of x, that of x, is the same as f of x, the antiderivative, from a to b. And this is the same as f capital of a, like of b, minus f capital of a. So f here, f of x, is called the what? The antiderivative function. Is the antiderivative function of the function f of x. Okay, this means, what does that mean? If I do derivative for the large one, for the antiderivative, I'm gonna get the small one of x. Okay, this is the important things. The integral for the f prime of x from a to b is the same as f of x, but you can plug the values from a to b. This is the same as f of b minus f of a, and this is called the net change. Net change. This things here is called the net change. Means if I have derivative inside, if I have a derivative inside the integral, I can get like the derivative and the integral, they can cancel out. The derivative and integral, they can cancel out. This is the important things about the net change. Here I'm gonna give you the formula. The net change said, if I have, for example, integral, and inside the integral there is derivative, the integral with the derivative, they can cancel out. I will get f of the function, the f inside the function. So this is the same as f capital of x from a to b. Okay, the derivative and integral, they can cancel out. Now, the last 6 things in this section you should to know. The derivative of position, what they give me? What's the derivative of like the object or position of the object, as we learned before? Velocity, correct. What's the derivative of velocity? What's the derivative of velocity? Acceleration, nice. Now, what's the integral of acceleration? I'm backward. What's the integral of
Velocity.
acceleration? Velocity. What's the integral of velocity? What's the integral of velocity? Position, correct, nice. So this is what the last things in this section. They said, I'm gonna like write it like this. S means position. V, what's the meaning of V? It's velocity. A, what is the meaning of A? Acceleration. Nice. If I go like this, I do derivative, I'm gonna get everyone here derivative. The derivative of S, they give me V. The derivative of V, they give me what? A. Okay, if I backward, I would like to backward. The integral of S, what's the integral of S? What's the integral of S? I mean like the integral of A is V. The integral of V is S. Okay. Nice. Okay. So by these things, I can like build a new information too. I can say like now, so by before, we learned that S prime of t, the derivative of S is what? Of V of t. So today we're gonna learn like the integral. So the integral from t equal 1 to t equal 2 for B of t is the same as S of t. And then you can plug the values. And this is the same as what? This is the same as S of t2 minus S of t1. Makes sense? This is called the displacement of the object during the time period from t1 to t2. This is called the displacement of the object during the time from t1 to t2. It's called what? Displacement. Okay. If we need to find the distance, we're gonna take the absolute value of this. If my question is find the distance, you're gonna put the absolute value for this. The absolute value of this means you have to find the positive things of these things. Make sense? So my question now, I'm sorry. If we need to find the distance, we're gonna use distance by using the integral for the absolute value of V of t. Not the same like before, but we're going to use the absolute value here, t1 to t2. So this is called the total distance traveled. Okay. By the way, if I want to like show you exactly what is the mean of the absolute value of V of t, means it's equal V of t if the function is positive. If the function is negative, you have to multiply by a negative V of t. So V of t is the object move to the right. Here the object move to the left. Okay, the last thing is the acceleration. So here the acceleration. The acceleration of the object A of t. This is the same as V prime of t. The derivative of V, they give me what? Acceleration. Wait, can we scroll up the scroll up a little? What do you mean like scrolling up the little? Zara.
Oh, I missed the notes. Like, I think it was the
Oh,
formula.
you wanna like? Okay, sure. Like here we go.
Yeah, thank you.
So SBA, if I do derivative from left to the right, the derivative of S, they give me V, the derivative of V, give me A. If I want to do integral from right to the left, the integral for A, they give me V, the integral of V, they give me S. The quiz start at after 8 minutes, but I'm gonna like post it. Yeah, I'm gonna like start it at 12 o'clock if you don't mind. Yeah, the acceleration of the object AT equal the V derivative of t. So this is mean the integral for acceleration del of t from t equal 1 to t equal 2 equal v of t2 minus v of t1. Okay, this is the change of velocity from t1 to t2. The change of velocity from t1 to t2. Last example, then I'm gonna go over the quiz. So here's the example. Who will read the example? Who can read the example, please? Yeah, go
A
ahead.
particle moves along a line so that its velocity at time t is vt equals t to the power 2 minus t minus 6 measured in meters per
Okay.
second.
Okay. Part A, find. Yeah, go ahead. What's that for part A? Find the displacement of the practice during the time period from 1 to 4. The second part, find the distance of the traveling. Okay, for the first one is easy. Like, you know why? Because we're gonna like use to find the displacement by using this formula. Here's the formula. Is the same as the integral of v of t, because the integral of v of t, they give me s of t. Okay, what's the integral of v of t now? What's the integral of v of t from t equal 1 to t2? What is v of t? What is v of t? Is this function? This is the v of t. Be like t squared minus t minus 6 del of t. What's the limit of the integral? 1 to 4. Okay, what's the integral for those things? What's the antiderivative by using the table? By using the table, what's the integral? T to the power 3 over 3 minus t squared over 2 minus 6t. I'm gonna do it very quick. Then you have to plug the value of 4 and the value of 1. Plug the value of 4, what do you get? 4 to the power 3 over 3 minus 4 squared over 2 minus 6 times 4 minus, plug the 1, what do you get? 1 to the power 3 over 3 minus 1 squared over 2 minus 6 times 1. Now the answer is what? The answer is minus 9 over 2. This is equal minus 9 over 2 after you finding the calculation, and this is equal minus 4.5. What does the minus here mean? Minus 4.9, 4.5. What is the meaning of minus? The minus is for the direction. What does that mean? Means the object move 4.5 distance with direction. What's the direction? Left or right?
Left.
Left, correct. Exactly. With direction to the left. Okay. This is the displacement. Now for the second one, find the distance. For the distance, you're gonna find the integral for the absolute value of v of t, del of t, from t equal 1 to t equal 2. T equal 1 is 1 up to 4. Okay, the absolute value of v of t, you're gonna like find the absolute value. You're gonna find what is exactly the function is positive and negative. So my function v of t is the same as what? T squared minus 6 minus t minus t minus 6. Okay, how we can find the sign of this function? So first of all, you're gonna find the factor. What is the factor of this one? T minus what? What is? Give me two numbers. The multiplication is 6, and the addition is minus. The multiplication minus 6, and the addition is minus 1. It's t minus 3, and t plus 2. Then you have to find the zeros. What's the zero for these things? What is the zeros? This is equal
We
to
get
0.
negative 2.
Exactly. Negative 2 and 3. Okay. Now you're gonna check the sign. Pick any values here. For example, minus 5. Pick any values here. For example, 0. Pick any values here. For example, 5. Now, what's the sign here when you plug the minus 5 inside this function? Minus 5 squared is positive, and here is again positive, and here's again positive. So minus 5 squared is 25, plus 5 is 30, minus 6. 30 minus 6 is what? 24, positive. So the sign here is what? Positive. Same things if you plug the 5, you're gonna have the same things, positive. But if you plug the 0, you're gonna what? 0 squared minus 0 minus 6 will be what? Minus. But actually, if you look into the interval starting from which value? From 1 to 4. So here is the 1. Here is the 1. You're starting from this point up to this point. Yeah, I'm gonna move the 5 up to here. Here I'm gonna like make it more bigger. This is the 5. Okay, this is 4. Here's the 4. This is 4, and this is what? Is 1. So look, from 1 to 3 is negative, and from 3 to 4 is positive. So you're gonna multiply the function v of t. This is equal what? The integral from 1 to 4 of v of t, the absolute value del of t, is the same as the integral from 1 to 3 multiplied by a negative v of t, del of t, plus the integral from 3 to 4 for v of t. Why multiply by negative? Because it's negative here. Because it's negative. Because it's negative, I have to multiply by negative. Why here I keep it positive? Because it's positive. Anything has negative, you're gonna multiply by negative. Okay, I'm gonna do it very quick. So the integral for v of t del of t from 1 to 3 is the same as negative t to the power 3 over 3 minus t squared over 2 minus 6x. Minus 60. And the interval for this integral is 3 to 1, from 1 to 3. Plus the same things, t to the power 3 over 3 minus t squared over 2 minus 60 from 4 to 3 to 4. 3 to 4. Okay. You're gonna plug these values inside this, inside this here, this equations, and the answer, it will be like this. After like you plug in the values, you're gonna get 61 over 6, and this is the same as 10.17 meter. Make sense? Okay, I'm gonna like show you exactly how you plug it. I'm gonna do it so quick. So it'll be like negative 3 to the power 3 over 3 minus 3 square over 2 minus 6 times 3. This is for the first one. Now negative will be like positive, because negative times negative will be positive. You plug the 1 to the power 3 over 3 minus 1 to the power square over 2 minus 6 times 1. Okay, and for the second equation will be like positive plus, you're gonna plug the 4 to the power 3 minus 4 to the power 2 over 2 minus 6 times 4. Negative, because like you're gonna subtract for the second limit, 3 to the power 3 over 3 minus 3 square over 2 plus, minus 6 times 3. And the answer, the final answer is 61 over 6 is the same as 10.17 meters. Any questions?
Well, if from 1 to 4 was just positive, then we don't have to multiply by negative, right?
From 1 to 4? Where's
Yeah.
the one? From 1 to 3 is negative. You see the negative here? So you have to multiply by negative.
No, if it was like
And-
1, 2, 3 is positive,
Yeah.
then
Yes, if it's positive, you don't have to do anything. Just you're gonna get like one limit from 1 to 4. You don't have to do this things. You're gonna
what
like
if the
right
3
here,
to 4 was negative?
which one is negative?
3 to 4 was negative.
3 to 4 is negative. You're gonna like multiply one negative from 1 to 4 like this, and one integral. If from 1 to 4 is all of them negative, just you're gonna get one integral.
No, I mean like 1 to 3 is positive, but 3 to 4 is negative.
1 to 3 is negative here, right?
Yeah.
Okay, you're gonna multiply by negative. Anything you have a negative, you're gonna multiply by negative. The positive, you're gonna keep it positive. Make sense?
Yeah.
Okay.
Thank you.
Any other question? What's happened to the absolute values? The absolute values, they change. Like the absolute values, they change. The negative, you multiply the negative by negative, and the positive, you keep it positive. That's it. Freddy, what happened to the absolute value? Like the absolute value mean anything is negative, you're gonna multiply by negative from 1 to 3. Anything is positive, you're gonna keep it positive. Yes, okay. Another question? Okay, no questions. We're gonna stop up to here and get ready for the quiz. Okay, I'm gonna stop recording.